Okay, so we have problem 3 here, and we always want to start by finding the inflection point. So looking at this equation here, we have a positive 4 on the inside, so that means we're shifting left 4. And if we have a negative 1 on the outside, that means we're going down 4. So this is going to help me find my inflection point. So we always start from the origin, and if we're going left 4, well, that brings me here, and then I have to go down 1. So I have to plot my point right there. So I'm going to grab my marker and plot that point. Now, based off that coordinate that I've just plotted, I need to know what that point is and write it here for my inflection point. So that coordinate is -4 and -1 for the y value. Okay, inflection point done. Now I have to figure out what 2 other points to plot, because remember, a cubic function needs 3 points. So we still need 2 points. Now, if you watch problem 1, the video for problem 1, you know that we can also use the slope to help find the other 2 points. Now, if you haven't watched the video for problem 1, I would watch that video first before you watch this one. So anyhow, we need to find our slope. So in this case, our slope is the number in front of our x. So our slope here is -2. So slope is -2. Now we can always put a number over 1. So we can have the rise over the run. Now in this case, from the inflection point, so here's our inflection point, we have to go down 2 and over 1. So here's our new point that we need to plot. Plot that right there. And remember that when it comes to cubic functions, that they have this symmetry. So if this point went down 2 and over 1, that means I go the opposite direction to find the other point from the inflection. So I have to go this time up 1, but over to the left, up 2 and over to the left 1, and plot that point there, which is about here, right? And then from there, all I want to do is draw my cubic function. So it looks like it's going up first, right? Because in this case, we have a -2 in front of this equation, so we can see that it's actually up first. And then we're going to go down. And there we have it. We have our cubic function. Let's also find the y-intercept. Remember, the y-intercept, our x value is always 0. So if x is equal to 0, I need to find my y value. So I plug in 0 in for x. So I'm going to set that up to find my y. So I have -2, plug in 0, so 0 plus 4 cubed minus 1. So if I work this out, remember PEMDAS, so you always want to work inside the parentheses first. So 0 plus 4 gives me, that's a highlighter, my bad. So there we go, -2. So 0 plus 4 gives me 4, and then that's going to be cubed minus 1. Well, 4 cubed, that is going to be 4 times 4 times 4, which is 64. And that is multiplied by -2. So -2 times 64, that's going to give me -128, and if I subtract 1 from that, that's going to give me -129. Wow, that's a big number for y. So in this case, my y-intercept is at 0, -129. Now, we're not going to plot the y-intercept. That'd take us a while to plot because it's really far down on the y-axis. So we're just finding the y-intercept. And remember, domain and range for all cubic functions, what is that? Well, that's going to be all real numbers for both domain and range. And that's because for a cubic function, it always points towards the left, it always points towards the right, and it always goes up, and it always goes down. So there's no stopping point in this case. So that's why domain and range is always all real numbers. And that's it.